Okay, let's move on to number 19. Again, they give us the probability model here for number of repair calls they could receive during an hour and the probability of it. So how many calls should they expect in the next per hour? So again, those are very, very similar to the ones from earlier. 0 calls, zero point 0.1, you can pretty much ignore that in your actual calculations, but you should write that out on the AP exam just to prove that you understand all of them should be included. So that's an average then of 1.7 calls during an hour. Now, here's the part that's very different from what we've seen before, the standard deviation. Keep in mind that standard deviation is simply the square of the variability. So to figure out the variability of the number of calls, we're going to take, again, that number that we just found of the 1.7 calls over here somewhere, and we're going to go back one by one and take that expected outcome of 0 minus the value that we found there for mu and square that and multiply it by the probability. Then we'll take 1, subtract the 1.7, square that, multiply its probability, etc., etc. Now, this in the end gives us the variability, 0.81. To convert that into standard deviation, then we need to take the square root of that. And hey, how interesting, the square root of 0.81 turns out to be exactly 0.9. So again, that basic relationship there, that the standard deviation is the square root of the variability. We're going to have to keep that in mind and use that basic fact as we go through these. Okay, for 22, looking at things not from your standpoint as the policyholder, but from the standpoint of the insurance company itself. So for part A, create the probability model here for the profit that the company makes on a particular policy. Well, if the person holding the policy does not have any injury, they make a profit of $100. If they suffer a major injury, well, they've received 100, they have to pay out 10,000, so that's a loss of $9,900. And same thing with a payout for a minor injury, it's a loss of $2,900. Okay, so now probabilities. They say that each year it's 1 out of every 2,000 that have a major injury, so that's how we get the 0.0005. 1 out of 500, so that's the 0.002. Add those together. Again, there's only 3 outcomes: major injury, minor injury, no injury. So add those together, subtract it from 1. So that's how we get our probability here of 0.9975. The expected profit on this policy, then, as usual, multiply down your columns, combine those, and the company is expecting to get $89 in profit for every policy that they sell. All right, now standard deviation, that's going to require a little bit more of the calculation here. So, I'm sorry, went a little bit too far there. I still want to see those probabilities. So again, it's each profit minus the mean that we just calculated of 89 multiplied by the probability. Um, yeah, so you're subtracting a negative from a negative, but you're squaring it. And then multiplying by a really small number. So 67,879. That's the variability. Take the square root of that. $260.54. 24. Suppose we're going to do some day trading. All right. So um, should she buy that stock option? Well, what's the expected outcome? If she does this over and over again, what's the mean? How much is she going to win? How much is she going to lose? All right, so we take the worth. Notice here how they didn't ask for the probability model, so they stopped making a chart. So for part A, we're going straight to the expected outcome calculations. So it's going to be worth $1,000, but that's only going to happen 20% of the time. It'll be worth nothing 30% of the time, and it'll stay worth $200 50% of the time. So again, find those products, add those together, $300. Um, yeah, that stock option there seems like a good idea. The expected value is 300. They only have to pay 200. So ooh, wait, hold on. How much did she expect to gain? We could probably just subtract that, couldn't we? And they're showing you here in part E, going through and doing those same expected outcome here, but looking at how much they gained. So pay the 200, it's worth 1,000. That's a gain of 800. Pay the 200, it's worth nothing. You've lost 200. Pay 200, it's worth 200. The gain is 0. And hey, what do you know? Just as expected. Now, hopefully you're getting used to calculating then the standard deviation of the gain. So again, the gain we're saying is $100. So 800 minus the 100, negative 200 minus 100, 0 minus 100, multiply by the probabilities. After you square those, take the square root. And oh, what do you know? For C, standard deviation of the trader's gain is the same as the standard deviation of the stock option itself. Okay. And then 25. Um, you're playing somebody who's a lot better than you are. I don't know what contest this is. Um, so for part A, no, they're not independent. They tell you if you lose the first game, the probability that you win the second one, this value is different than this value. So no, those are not independent. Um, so let's calculate probability of, wow, so negative, losing both games. So your probability of winning the first is 0.4, your probability of losing the first is 0.6. The probability of losing the second one, given that you lost the first one, again, the probability of winning the second is 0.3, so the probability of losing the second is 0.7, so we get a probability there of 0.42. For part C, the probability of winning both games. All right, so those numbers they gave us here at the beginning, the probability of winning the first game is 0.4. If you win the first game, the probability you also win the second one is 0.2, so there's no real calculation to find that. Probability of winning both games is well, that's kind of a sad 0.08. So if our random variable x is the number of games you win, the probability model is going to be our lovely little chart here. So you could win none of the games, just one game, or both games. And we've already figured out from part B, the 0.42 probability of losing both of them is here. From part C, the probability of winning 2 games is here. There were only 3 possible outcomes. Add, oh look, 0.42 and 0.08, that's 1/2. The probability of you winning one of the games is 1/2. Hey, that doesn't sound too bad. Part E then, expected value, the expected outcome here. So again, you're going to multiply down your columns. 0 times 0.42, 1 times 1/2, 2 times 0.8. You're going to win 0.66 games. And again, this is the usual spiel here with our variation difference between 0 minus 0.66, 1 minus 0.66, 2 minus 0.66. Square those, multiply by the probabilities, take the square root to knock it back down to standard deviation.